Alright, in this problem here, we have an equation, xy minus sine, and the argument of sine is xy equals to 2, and they want us to find d sub x y. Now, if you haven't seen this notation before, it's just a fancy way of saying, hey, can you find the derivative of y with respect to x? Alright, so this notation here simply means, can you find dy dx? Well, let's see. This is not set up in your typical function form where we have, y equals some stuff, or f of x equals some, and everything else is on the other side some stuff. So we need to use a rule called implicit differentiation. Right? So we're going to find the derivative of this equation, but we're going to do it with something called implicit differentiation. That's a big word. Differentiation. Okay. It's a trick of calculus here that we can use on non-functions like this guy right here. So to use implicit differentiation, we need to know things like the product rule. We need to know things like the chain rule, and just about every rule, maybe even the quotient rule, not necessarily in this example here, but implicit differentiation relies on prior rules that you have learned. Okay, so let's dive into this problem here. It's got some heavy algebra in it, so I hope you're ready for this. Alright, heavy algebra. Alright, let's see if I can break this down. Let's take the derivative of this stuff, xy. Do you see that this is really just a product? Right, it's just a product of x times y. So I'll tell you what, let's invoke the product rule, and let's say that in this case here, this x is going to be my f, right? And let's make the y here our g. And so using the product rule, you can see pretty simply, pretty easily, that the derivative of f, which is just a 1, right, times my g, which is just a y, right, and we'll clean all this stuff up later, plus f, which is just my x, times the derivative of g, which g in our case is a y. Now, I can't take the derivative of y with respect to x because there is no x. Right? There is no x in this thing here. So I'll just have to write it and leave it in this form of dy dx. Okay? In fact, that's what we're after. Look at that, right? That's what we're after over here. We want dy dx all by itself. So keep that in mind as we go through this problem here. Okay? Alright, so what I have written out here is simply the product rule, and it's the derivative of xy. Right. Let me clean that up just a little bit more, and then I'm going to go and tackle the rest of this here. But let me clean this up a little bit. 1 times y is simply y, and x times dy dx is simply, well, it's just x times dy dx. But I'm not going to write the parentheses anymore. Okay, I'm not going to write the parentheses anymore. All right, let's keep going. I've got minus sine of quantity xy, so this is the argument. Xy is the argument for sine. And to take the derivative of this thing here, we need to use the chain rule, right? So let me cover this up for just a second here. Right, let's cover this up. The argument for sine. What is the derivative of negative sine? Oh, the derivative of negative sine is just cosine, right? So this, I can just bring this minus sign on down here and say, hey, the derivative of sine is cosine of the argument is whatever I was just covering it up a second ago. So that is the chain rule right there. That's the chain rule in action, but it's just for the outer function of sine. Okay? Now the chain rule says go inside, right, into the inner function here, xy, and give me the derivative of that. And that, whatever that comes out to be, is what we're going to multiply, right, by the derivative of the outside. So let's see if I can do this here in a different color. So what I've done so far is this was the derivative of the outer function, right? And now I want to take the derivative of the inner function. The outer function being sine, the inner function being xy. Well, do you see that the inner function being xy, I want the derivative of xy. Hey, I just found that a second ago, right? I just found that a moment ago. So in fact, it's this thing right here. It's y plus x times dy dx. So instead of doing this all over again, why don't I just write down the derivative of the inner, and I'm just going to copy it from right here, what I've got. Y plus x times dy over dx. There we go. So chain rule, derivative of the outer times the derivative of the inner. Now the derivative of the inner has two terms in it, right? It has two terms in it. So what I'm going to do then is I'm going to take this term that's in front of it here, and I'm going to distribute to both of these inside my square brackets there. Okay? And I'm going to put all of this on one line. So here goes. I'm going to put all of this on one line. I've got y plus x times dy dx. Again, that was the derivative of this first product that I found, right? And now let's distribute. Ready? Let's distribute. What is negative cosine of xy times y? Well, I'll just write it like this. Minus y cosine of xy. Okay? And now let's distribute these two. What is negative cosine of xy times this second term in here, x dy dx? Oh, that's just negative x cosine xy of, or times dy dx. Okay, and I'm kind of running out of room here. Maybe I should have turned the paper horizontally, right? But I hope you see that I've got one more thing to do, and that is on the other side of this equal sign I've got a constant, which is 2, and the derivative of a constant, I don't care what its respect to, right? The derivative of this constant, in this case with respect to dx, is just a 0. So I've got an equals 0 sitting there, okay? So all of this stuff that I just wrote here in green, all of this stuff here is just equal to 0. Alright, now this is the derivative using implicit differentiation, alright, of the equation that we started with. But we are after dy dx. This is what we want. So I'm going to pause here for just a moment. Maybe you want to work all this out. I'm interested in getting this dy dx and this one here, by the way, they're both the same. I'm interested in getting this dy dx all by itself. Okay? Really, you can stop right here because this is really just algebra. All right? I've shown you the calculus. This is all calculus up to this point. Getting dy dx all by itself is simply algebra. I can show you the algebra if you want, but maybe you want to pause the video right now and see if you can figure out what the algebra is. Okay, getting dy dx all by itself. So if you want to pause the video, go right ahead and then see what you come up with as an answer. I'm going to show you it in just a second here. Alright, so let's see, if you pause the video and you came up with an answer, let's see what you've got, okay? Do you see that this term right here, I'll put it in a box, this term right here has a dy dx in it, and this term right here has a dy dx in it, okay? But these two terms here do not have a dy dx in it. These guys right here don't have a dy dx. So let's leave them alone, and let's pull these terms together that do have a dy dx in it all by itself on the other side of the equal sign, okay? So I'm going to write it like this here. I'm going to write it like this. I'm going to bring this over. All right, I'm going to bring this over to the left-hand side of the equal sign, on the other side over here with this 0, which would make it positive, right? And I'm going to bring this over to the other side as well, which would make it negative. So I'm going to write it like this on the left-hand side. I've got x cosine xy dy over dx. Okay, that's positive now. I'm going to bring this over to the left side, which makes it negative x dy dx. And what remains on the right-hand side are these two terms here. I've got y minus y cosine xy. Alright, cool. So there's my equal sign. And I've got the left-hand side, I've got the right-hand side. Why did I do that? Well, I did that because I can factor out a dy over dx from both of these two terms here. And if I do that, here's what I have. Right, if I factor out a dy over dx from these two terms, do you see that from this term I'll have simply left an x cosine xy, and from this term I'll have simply left just an x minus x, okay, is equal to this stuff here. And I hope you see algebraically, if I want this dy dx all by itself, and it's right now being multiplied by this square bracket, then if I want to undo this square bracket, I'm going to divide both sides. All right, divide both sides by this good stuff here. So I'm running out of room on this sheet. Let me scoot over to the next sheet, and you can see what I've got here. All right, so let me scoot this up to the top and write it out this way. Okay, I now have dy dx is equal to, all right, the right-hand side of my equation was y minus y cosine xy, and if I'm dividing both sides by what was in that square bracket, I have x, I have x cosine of xy, just like that, minus x. Okay, all right, now there's one more thing I can do, and I can pull out of all of this stuff. Do you see that these two terms up top have a y in common? And if I pull that out, right, do you see that these two terms have a y in common? I'd be left with 1 minus the cosine of xy. And if I do that on the bottom, these two terms have an x in common. And if I do that, I'm left with cosine, let's see here, cosine xy minus 1, right? So there's a 1 there and there's a 1 there. Okay, well, man, I wish these two terms were exactly the same. Right? I wish these two terms were exactly the same, and then I could just cross them both out, right? These two parentheses, but they're not the same. Well, they're what some books call, what some authors call opposites, right? I'll put it in double quotes here because it's not necessarily a mathematical technical term here, but do you see that these two things right here, I'll put them in a square box, are opposites of each other, right? They're opposites. Look at my fingers. Like the order of this here, this difference is reversed from this one, right? So they're kind of flipped over there. Well, anytime you come across opposites, you can cross them out, right? You can cross them out as if they were exactly the same, but instead of just crossing them out and replacing it with a 1, you cross them out and replace it with a negative 1. Cool. Okay, so my final answer then is, all right, I have negative y over x, and that's what dy over dx is equal to. Right? And again, that negative sign came from crossing out the opposites right there. All right, cool. Hope that helps.